Okay, welcome to the part 2 of the organic chemistry series. I've already uploaded the part 1 and I hope that you watch it and you are waiting for the part 2. We are in the part 2 in which we are going to continue from where we get left over there because it was like it was keeping long. We ended at the classification of organic compound. And for that we talk of in the part 1 we talk about the first one, which is the aliphatic and the alkylic, and it was left with heterocyclic compound and aromatic compound. Please do well to watch the first video so that you can understand it clearly. Are you getting me? Okay, so let's move on to the left one, that is the heterocyclic. Now for the heterocyclic, it is emphasizing on that these are molecules which consist of two rings of carbon, which consist of closed ring of carbon atom, in which the ring includes other atoms such as oxygen, nitrogen, or sulfur. Go for the heterocyclic. The hetero here means many, or it can be of different, something like that. Different. Go for this one. It is similar to the alkylic, but for the alkylic you need to include all of the ring need to be carbon atom, but for the heterocyclic we have to get either oxygen, nitrogen, or sulfur in the closed ring. So now let's emphasize on this example given here. We are having this closed ring. We are having this closed ring. So for that, I can just say that this one we are having E, carbon, 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 and here is sulfur. Go for the closed ring, we are having sulfur in between. Go for this one, it qualifies this. When we consider the definition of the heterocyclic compound, this one qualifies to be a heterocyclic compound. Are you okay for it? Okay, so that is for the heterocyclic. The cyclic means you have to be closed. You have to form something like a ring. And for that, we got this as an example, which we are having sulfur to replace one carbon in it. The name of this one is just called thiophene. Yep, I think so. The name of this compound is thiophene. We'll talk about more. Now, the last classification of organic compound we'll talk about is the aromatic compound. For the aromatic compound, these are compounds which contain one or more benzene rings. Now, when we are to talk about benzene is just with a chemical formula HK. It's having this like a chemical formula, that is what is termed as benzene. The structure of benzene is looking just like here. So when we count, we are having carbon 1, 2, 3, 4, 5, 6, and hydrogen of 6, giving to be the formula for benzene. Okay, so now this be the aromatic compound, and it is emphasizing that every aromatic compound need to have one or more benzene rings. Now, for a benzene ring, it is having an alternating double bond. I think double bond over here, and here will be single bond, and double bond will be here, and the next one will be single. It is the double bond is alternating. For the double bond, one of the bond is sigma bond and the other one is pi bond. For each we are having a sigma bond. We will talk about sigma bond during this topic. Hybridization. We'll talk about more about sigma and pi bond over there. So you can go ahead and find a video of that, or wait for me to just clip that for you to get it. And this one, we are having a pi bond over here, sigma bond and a pi bond. That is how the dicting how the double bond have been alternating. One of them is a sigma bond, one of them is a pi bond. So don't worry, that is one example. Or this can be reduced. It can be reduced into this structure. It can be reduced into this structure. This one over here. When we just draw it without and each joint, there is no any atom over there. It means that it is carbon. Take note of that. I can replace carbon over here, or I can choose not to bring the carbon. You have to be able to get it. Are you getting me? Another example is this one. Here we are having a crow ring. We are having the crow benzene ring, or benzene ring like that, and there is OL over there, making the compound to be called phenol. When we get to the naming of organic compound, we'll be able to understand why it is having the name phenol. So don't worry, we'll get to the naming of organic compound. Okay, so that is one example. It is having the benzene ring and the OH being added to it. Are you getting it? Okay. Now, let's try our best to see if we can answer the question over here. You can just pause the video and try it yourself. You can pause the video over here and try it yourself. Here and get categorize the following organic compounds into aliphatic, alkylic, heterocyclic, and aromatic. Here is the compound. Here is the compound, and again there is another example over here up to each. So you can pause the video so that you'll be able to solve it yourself. After that, you come in. Welcome back. Now let's try to solve them. I just draw the table over here, which I'm having aliphatic, alkylic, and heterocyclic and aromatic. So when we just look at it and it is alkylic, we just find it under it very clearly, just like that. Okay. So let's look at the A. Let's look at the A. When we just look at the A, we are having the benzene ring over here, and another one. Since it is having the benzene ring, therefore you qualify it to be an aromatic. So I will have I'll have over here to be A. So the A over there is aromatic compound. Now let's look at the B. The B here is a straight chain. Don't worry that I've been branching. It's a straight chain. They just put it over there just to confuse. Go every straight chain of go. When you just, if you have watched the first video, I explain a lot about it. When it is a straight or a branched carbon chain, therefore it qualifies to be an aliphatic. Would it be an aliphatic compound? Are you getting me? Okay. Another one we can talk about over here is this one. When we consider the E, we are having carbon being bonded, and there is a ring. Since there is a ring, we won't consider what is there again. we are considering the ring. So think it is a ring. Think we are having the ring over there. Then for that, it qualify it, and it is made up of only carbon atoms. We qualify it to be an alkylic. So the E is an alkylic compound. Now let's look at the D. The D over here also, we have here, I think there is no anything. It is carbon, 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 and here we are having oxygen. I think we are having oxygen over here, therefore it makes it to be heterocyclic because it's a closed ring in which it is involving either sulfur. When we just look at look at the definition for heterocyclic over here, that includes other atoms such as oxygen, nitrogen, or sulfur. So here it includes oxygen, nitrogen, or sulfur. So for the D over there, the D over there can be classified under heterocyclic. So D is a heterocyclic compound. Okay, let's go to the E. The E over here, the E over here is the E over here is a cyclic. So we have carbon here, carbon here, carbon here, carbon here, and since there is no any other atom over there, therefore each joint is a carbon. If each vertex is a carbon, so for that ring it is alkylic because it contains only carbon in the closed ring. So E is an alkylic. Now let's consider the F. The F also, you can consider that it is having the benzene, but here it is a closed ring, but there is nitrogen over here. So it is not carbon. So for that, it qualifies it a closed ring with either nitrogen, oxygen, or sulfur being a heterocyclic. So for that, we are having a heterocyclic over here. So F is a heterocyclic over there. Now let's look at the G. The G, we are having a straight chain and a branched. We think there is a branch, then it qualifies it to be an aliphatic. Please watch the first video so that you can understand this clearly. So G is that. Now let's look at the last one over here, H. So the H over here. Now I just forgot the ring of benzene can be reduced into this form. Let me just emphasize that so that you can get it clearly. The ring of benzene, I can just have my hexagon, just guided figure just like this, and instead of the alternating like this, then I can just draw a circle in it and it represents benzene. So when we look at there is a benzene over there in which there are OH, other capital, and that is the hydrogen, and also the E3, that is the methyl group over there. So for this, since it is having a benzene ring, then it qualifies to be an aromatic compound. So that is H. That is it. So it seems the video is getting too long. So let's end here. Go over, and I hope the understanding is clear. If you are having any question, leave it in the comment section below. Please like, subscribe, and share for me to get motivated to do more for you.